This next lesson is about triangles. So the goal of this lesson is to give some definitions and classify special triangles and how their parts are related. So here's a few vocabulary terms that we will develop definitions for. But to get started, let's look at triangles. So looking at this diagram, and you can see this also on your guided note sheets, which parts of these lines are perpendicular, which ones are parallel, and how do you know? So take a minute on your own and look at the diagram and try to determine which ones are perpendicular, which ones are parallel, and how you know those to be true. There are a few markings that we're going to use to determine perpendicular and parallel lines. First thing we know about perpendicular lines is they are lines that intersect, and they intersect at a 90-degree angle. And parallel lines, we know they are lines that are in the same plane that never intersect. So the pair of lines that are parallel are going to be marked by these arrows, indicating that these two lines are parallel. Now, they all look parallel, but you can only conclude that line AB is parallel to line CD because it has the parallel markings. Perpendicular lines, you can conclude that JK is perpendicular to JM because they intersect at a 90-degree angle, and we have the marking to show that. Line JK is perpendicular to line JM. Now, as of now, we don't have any theorems that tell us any of those other lines in that diagram are perpendicular. Now, a second question regarding these diagrams is which pair of triangles are congruent, which is not typed on there, but I missed it. So which pairs of triangles are congruent? So take a minute and see if you can determine which pairs of triangles are congruent. And you may want to pause the video while you figure it out before I give the solution. So with congruent triangles, we have to line up corresponding sides with corresponding angles. So triangle UVT does not give any indication of congruent angles, but we know angle TUV is congruent to angle Z. We know angle UTS is congruent to angle Y. And we know angle S is congruent to angle X. So those are our corresponding angles, but let's also look at our corresponding sides. Side UT is congruent to side CY. Side ST is congruent to side XY. And side US is congruent to side XZ. So therefore, we can conclude that triangle UTS is congruent to triangle ZYX. Again, remember you have to line up your corresponding angles and your corresponding sides when you write the statement of congruence. In geometry, we have to be very careful when we're assuming things. So to assume something is to accept it as true without facts or proof. Sometimes we'll have diagrams that make triangles look congruent or make lines look parallel or perpendicular, but if it doesn't have, if there's no evidence showing that they're congruent, you may not assume that. So just because two angles look congruent does not mean they are. When you're using vocabulary, especially related to diagrams, but all the time, make sure that you use proper language. The difference between a right word and an almost right word is like calling a lightning bug lightning. It's close, the vocabulary is close, or it looks close, but those are two very, very different things. So, for example, triangle ABC, angle ABC is not the same as angle BAC. In one case, we're talking about angle B, and in the other case, we're talking about angle A. So, although it looks close, the terminology looks close, it's not at all the same. So some things that you may assume are that two lines are straight. So if it gives you a line, you can assume that the line is straight. And if they intersect at a point. You may assume that. You may also assume that all points on a line are collinear. And all points in a diagram are coplanar unless they're drawn to show that they are not. So, for example, all of these points are in the same plane, but if a diagram shows that they are not, let's use a different one. So the diagram looks like a three-dimensional figure. It's intentionally drawn to look like these points are on different planes. So you may assume that those points are non-coplanar. Things that you may not assume are that lines are parallel. So these lines here are not parallel. You may not assume that they are parallel. However, these lines here, you may assume they are parallel, or you may conclude they are parallel because they have the parallel line indicator. Perpendicular lines do not assume that lines are perpendicular. These look like they are perpendicular, but you cannot conclude that because you do not know for sure that those lines intersect at a right angle. Here, you may conclude that those two lines are perpendicular because they intersect at a right angle. You may not assume that a pair of angles are congruent unless they are marked congruent. You may not assume segments are congruent unless they are marked congruent. And you may not assume polygons are congruent unless they are marked congruent. On your own, take take a minute to complete this example. In the diagram, which pairs of lines are perpendicular, which pairs of lines are parallel, and which pair of triangles is congruent. You may recognize this as the same example from the beginning of chapter of the lesson, but now you can clearly see these are marked parallel, these are marked perpendicular, and these two triangles are marked congruent. Take a minute to look at the two groups of triangles and create a definition for right triangles. A right triangle has one right angle. There's only going to be one right angle in a right triangle. Look at the acute triangles and the non-acute triangles and create a definition for those. An acute triangle has three acute angles. It's not enough to have just one acute angle or two acute angles. These both have two acute angles. However, this is classified as a right triangle because it has a right angle, and we'll get to the classification of the other one in a second. But all acute triangles have all three angles that are acute. Take a minute to look at the obtuse triangles and the non-obtuse triangles. An obtuse triangle is a triangle with one obtuse angle. Each triangle only has 180 degrees, so you won't be able to get a triangle that has more than one obtuse angle, because it then becomes some polygon larger than a triangle, 4 or more sides. So each obtuse triangle has one obtuse angle, which means one angle measuring greater than 90 degrees. Here is a quadrilateral. Here is a right triangle. And here is an acute triangle. Take a minute to look at the scalene triangles and the not scalene triangles. These measurements are measuring the sides of the triangle, not the angles. A scalene triangle is a triangle with no congruent sides. All sides of the scalene triangle have different lengths. Take a minute to look at equilateral triangles and not equilateral triangles. An equilateral triangle is a triangle that has 3 congruent sides. So all 3 sides here are congruent. All 3 sides here are congruent. Here, this is a quadrilateral, so it has 4 sides. These 2 sides are congruent, this is not congruent, and you know nothing about these sides. So you cannot conclude it's equilateral. Take a minute to look at isosceles triangles, and what do you notice? An isosceles triangle is a triangle that has at least 2 congruent sides. So here we see 2 congruent sides. Here we see all 3 sides are congruent, but that means at least 2 are congruent. Here we have 2 congruent sides, and here we have 2 congruent sides. With an isosceles triangle, it's important to know which sides and which angles they're referring to with the vocabulary that they use. The vertex angle is the angle between the 2 sides of equal length. The base of the isosceles triangle is the side opposite of the vertex. And then the base angles are the 2 angles opposite of the 2 sides of equal length. Here are the full definitions. I don't think these are on your guided note-taking sheets, but go ahead and pause if you need to clarify your vocabulary. I want you to summarize what we just covered in this video. So are there any triangles in 2 of the categories of this lesson? Please explain how you know. So please take a minute to do that. The extra example, locate point Z, and you need to label Z so that XYZ is isosceles. There are multiple solutions, so you need to find more than one solution. Please do that on your own. And then lastly, describe this triangle as precisely as possible. So you can classify the triangle, you can label or indicate which sides or angles are congruent, and please complete this on your own. All right, and that is the whole lesson for section 1.5. Please jot down any questions that you had during this video, and during class time we will address those. Thanks, ladies.